Good morning, good afternoon, or good evening, wherever you may happen to be, and whether you're watching live or archived. Welcome to the first in a series of collaborative webinars between Nautel and our friends at the Telos Alliance. We've got a lot of information to cover today. I am your host, Jeff Welton, and we'll get going immediately. First up, the standard housekeeping things. We do have a period for questions. As I said, we've got a lot of material. A lot of questions may not get addressed in this webinar, or if there's a question where I know the answer is coming either in this webinar or one of the future ones, it will be reserved for that point. So don't be disappointed if I don't hit your question as soon as you type it, but we are watching them all. Anything that doesn't get done in the course of the webinars will certainly be handled by email afterwards. So feel free to put your questions into the little question window on your control panel. We've got a stunning cast of characters today. Sorry, I'm tripping over my thumbs. I'm a little bit excited about this. You'll see why shortly. We've got number one with a bullet, a good friend of the family and a innovator for many years, the president or executive chairman and founder of Omnia, Mr. Frank Foti. Frank, welcome and thanks for spending some time with us today.
Jeff, always a pleasure, either with you or your crew, and to be, as I've said in other instances like this, being able to have a chance to share our story or our collaborative stories is always exciting. And the stuff that has been going on between our organizations, today's going to be the first, I guess, more along the lines of like public disclosure as to what's going on. And for those of you who are attending today, thank you, because you're going to really enjoy this. This is taking the next step. Again, thank you very much.
Going to be some fun. We've also got the Omnia product manager, Jeff Stedman. Jeff, thank you for coming with us today.
Thank you, Jeff. You have a great name, and I'm happy to be here. Happy to be here with Frank again, and it's been a real privilege to work with the team at Nautel in putting this together.
Okay, also on our side of the camera, we've got our Chief Technology Officer, Philip Schmidt, who I've had the pleasure of working with for many years now. And Philip, welcome aboard.
Yes, hello. I'm pleased to be on this webinar and share with you a little bit about the vision that we've been forming with the Telos Alliance over the last several months and year. Really, it's been quite the ride. So we're excited to share that with you, and I hope you stay tuned for not just for today's message, but for the following to come after this as well.
And last and certainly not least, our head of marketing at Nautel, Mr. John White. John, thanks for, I think you're the guy that kind of put some of this slide deck together. So I know you were working pretty hard on it this morning.
Well, thanks, Jeff. And thank you, attendees, for spending some of your busy time with us. These are busy days for you, I'm sure. And I think we have some exciting things to talk to you about. And I'll hand it back to you, Jeff. Thank you.
Thanks very much, and don't go too far away, John. I know you'll be up soon because we're going to start talking about exactly what this collaboration is and why, talking about some of the challenges and the technologies. So I'm going to hand it over to you to address some of this stuff, if you don't mind.
Okay, thanks, Jeff. So every once in a while, there seems to be this intersection of technology and relationships and problems to be solved. And I think this is one of those times right now. I want to thank Frank and the team from Telos for joining us in this collaboration. Our companies share very like cultures and a passion for innovation. And innovation is really about helping you find new ways to get things done. And Jeff, if you can flip to the next page. I guess I've always appreciated that we have many customers that value the role that companies like Nautel and Telos and other in the industries do to bring innovation and help solve new problems. Nautel started that way 5 decades ago with one of the first commercially successful AM at that time, solid state radio transmitters. More recently, I guess, and in my time frame with the company, there once was a time 10, 12 years ago when all high power transmitters were were tube transmitters, and we scratched our heads and put a lot of effort in, and I was very proud in those days when we kind of changed things by introducing the first affordable solid state FM transmitter. And I think, you know, that was a special time when AOP, audio over IP, the internet, all these things were converging. And I think we're really at another point in time when all those magical pieces are an opportunity for us in our industry again. And we spent a lot of time putting effort into user interfaces, and you've certainly seen us spend a lot of time on HD. And I know Frank, Telos Alliance has a great history of innovation as well too. Maybe you could speak to that about us.
Well, John, thank you very much. And before I talk to the Telos innovation, just need to share a real quick story, which predates my being involved, you know, as an entrepreneur. When I was working in New York at Z100, I remember distinctly a good friend of mine, Al Kirshner, who at the time was working at WPAT. He came over for lunch one day and he was all excited because he was putting in this new solid state AM transmitter from this Canadian company. I'd never heard of them before. And he said, he goes, Frank, I got to tell you something. These guys are going to change the transmitter or transmission industry. And this goes back to the 1980s. And I remember Al showing the, you know, I think it was the first Nautel transmitter in the New York City area. And I remember thinking, I got to keep an eye on these guys. And you know what, my friend? Damn glad I did. So speaking of the mid 80s and innovation, if I may say so, Telos was actually the first company to introduce the technology that we've all known as digital signal processing. They were the first company to introduce it to radio broadcasting, and this goes back to the mid 80s and Steve Church's development of the Telos 10 telephone hybrid. And I'm not going to go through all of the items that are on the screen here, but I think this timeline, which was wonderfully put together by our crew, sort of illustrates what we as an organization have done over the years. And I can honestly tell you that there were many times Steve, or when I say our Steve Church, he and I would marvel at the innovations that another Steve, who unfortunately isn't with us, and that being Steve Jobs of Apple, because we tried to adopt the same thinking, which was, what can we create that the marketplace needs, yet they don't realize they need it? And if you look at all the items on this screen, they all kind of hit that, you know, button on the head. And one of the reasons I'm really excited about today's event is that this falls in line with that message. And your organization has done that through the years. The casual conversations and even technical conversations that I've had with Phil and the rest of your gang have all fallen into that. And I think if we go to the next slide, it kind of ties together. And although the only thing that's missing on this slide here is some pasta sauce, because if you think back to it, I see Jeff smirking back there, you know, some innovation of being able to bring together the composite signal and the exciter or the transmitter, if you will, came together over a wonderful Italian dinner one night in Madison, Wisconsin, where we all put our heads together and we came up with what at the time we called Omnia Direct, but it was the first MPX over AES connection. And that kind of grew out of something that we had initially done in a very, it was a much more, it wasn't as elegant as what we created together with you guys, you know, that was done a number of years. But we were able to bring all of this together. And so, you know, what we're going to migrate towards today in this presentation just goes, you know, is an ongoing step in this journey and collaboration between our two companies. And it's something we're excited about. And, you know, more importantly, hopefully those that are attending and that'll have a chance to have access to this technology our goal is to make them as more excited than even we are. So at that point, again, thanks to one and all for joining us today, and carry on.
Thank you, Frank. And a little side note there, anybody does happen to be in the Madison, Wisconsin area, certainly take a moment to look up Vin Santo. You will not be disappointed.
You got that.
John, I'm going to let you carry on from there.
Thanks. And it's funny, Frank always seems to be, I know it's a cliche, but these things all seem to start on the back of a napkin. And
very true.
Very true. So, what's spawning this today? We've talked a little bit about our two companies and the heritage of innovation. And I talked a little bit about this periodic convergence of this technological and competitive relationships. And the landscape today, in my mind, radio has always lived in a very dynamic landscape, and maybe more so today than ever. Certainly our current situation in a pandemic world is that we've had to put everybody working from home. Some companies have been very innovative and started to look at virtualizing parts of the air chain. Even before all this started, the main studio being removed, that had changed the landscape in a fairly major way. And then we always are battling for the listener's ear. I put this graph on about podcasts because sometimes things kind of sneak up on you until you see them in the face, and they're right up in your face. And podcasts are about to break $1 billion. And some of our industry we're hearing are taking advantage of podcasts and adding those. And then others are looking at it as a competitive factor. So, and as we go through the rest of the presentations and through next week, we're going to talk a lot about managing technological complexity. Where's the right place for complexity? How can technology actually even hide itself? So that's kind of the landscape that starts to spawn where we're headed. And I know not everybody tuned in today will be have implemented digital radio, and some may not see it as something in their interest at all, but I think it is a toolkit for us that we all need to keep in our back pocket. And as we look at this moment in time and options for convergence of technology and opportunity, it's probably worth keeping digital radio in your back pocket with a fresh look to think of how can it help us. 65 million, this is the US stat, 65 million radio-equipped cars in North America right now. Markets reaching 40% penetration of HD radio. And opportunities are starting to arise that maybe we haven't seen before. But there's latest counts are 2,300 HD radio stations, and that means there's 13,000 that haven't converted yet. And that's part of what we're going to be looking at. We're going to be looking at a lot of things within the collaboration, but that's one of the trouble areas that we see. And for many, it's been too complex, too expensive, trying to find ROI. So we want to, through this collaboration, help answer some of those challenges. So that really is what the collaboration is about. We've been listening to you. We understand the challenges and the change that's going on in the industry, and we hope to apply our passion and our innovation to really come up with cheaper, easier, more flexible solutions for the air chain.
Now, that's all great, and that was a beautiful introduction, and thanks, John. And at this point, we need to hear some of the nuts and bolts. And when you come down to talking about the nuts and bolts and the technical stuff, who better to talk to than the engineers? So on our end, at that point, I'm going to bring Philip Schmidt into it. And Philip, before I forget, Raymond Fodge just dropped a note to say hello. So hello from Raymond, and let's go.
Well, I get to talk about the problems. Well, here we go. But I've also got the privilege of talking about the solution in a little bit as well. So first, let's have a look at the typical FM radio air chain. Now, I should put typical in quotation marks because there is no two radio stations that are the same. They're all set up differently, but they all have become more complex over time. We've had to add more boxes over time as we added more services from RDS to emergency alert to if you're one of the top markets, your ratings. It certainly has become more and more difficult. Any studio or transmitter site has many purpose-built boxes that take care of their particular focus. From what we hear from customers, they want to push most of the complexity back to studio if they can. However, that it depends on what STL equipment you have in place. It depends on where you run your audio processor. The STL could be licensed, unlicensed RF. It could be a T1, IP-based, you name it. There's so many variations. But ideally, we move things back to studio. But what do we do when the studio goes away? But before we go there, let's talk a little bit about HD radio. And certainly HD radio, it's clear, it's added even more complexity and certainly cost. The initial conversion cost to go HD radio was quite significant. And what we're looking at here in particular is essentially the third generation architecture as it was recommended 12, 15 years ago. And in that case, all of the HD equipment was recommended to be back at the studio or beyond the STL. That was to minimize the requirements on the STL bandwidth, because at the time, most people would have only had an FM STL for their FM main audio. But then the complexity, again, it starts with creating more content, creating more or installing more playout to handle your multicast channels. But then you also have to install all the HD radio equipment. A lot of times we had to install a second STL to carry the HD traffic up to the transmitter site. And not shown here, in the early days, most HD radio installations were dual transmitters, either space combined over two antennas or high level combined. Today the predominant method of combining HD is in the transmitter, but early on, HD radio really was a bolt-on. We just wanted to add the minimum. We didn't want to change the FM air chain at all, but just add on the HD after that. I think we're at a crossing point now where the HD is becoming more and more important, and it should not be. It's no longer the FM air chain that will drive our system implementation. So with this third generation, the problem that arose is because we had these parallel air chains. The first thing the challenge that was initially it flew under the radar because there were not that many HD radio receivers, but over time it became quite apparent that the throughput delay between the FM and the HD it's very difficult to maintain over such diverse paths when all the equipment's back at the studio. And just to put that into perspective, when the HD radio receiver blends from the FM to the HD simulcast, in order to have a good consistent blend experience, the NRC specification calls for 3 audio samples. That's 68 microseconds. So you need to steer your signal paths within 68 microseconds, potentially, hundreds of miles away, maybe not hundreds, but dozens of miles away, certainly, over various air paths, different equipment, and that has been quite the challenge. So the NRC has started a working group a few years back and drafted a recommendation, NRC G203, the IBOC time level alignment, and they recommended that all the HD radio equipment, or as much as possible, the best way to manage the blend experience is to move some of the HD equipment to the transmitter site. So next, yeah, there we go. So we've moved the importer and the exporter over to the transmitter, and that brought with itself some of its own challenges. If we move both the importer and the exporter to the site, now we have to carry all of the HD 2, 3, and 4 audio streams up there as well, where previously they were all encoded in the exporter and it was delivered as a single stream. Now we need to have multiple streams. The other recommendation was that if at all possible, rather than adding a second HD processor, you should really have a single FM HD audio processor with dual output. One to drive your FM signal and one to drive the IBOC HD radio HD1 signal. To have the best audio aura during the blend transition, so it sounds the best as the receiver blends from FM to HD. But now we've pushed a lot of complexity to the transmitter side. And going. And so in summary, even the analog air chain is very complex. Many purpose-built boxes, and there's an example to the right there. And HD radio hasn't helped the case in terms of transmission complexity. Oftentimes it's been bolted on, like we mentioned, and the diversity delay is a known industry problem that needs solving. Most of the complexity is at the transmitter side. And really what it also means, it's difficult for a fleet of transmitters to, either to upgrade the entire fleet and then also to maintain it. All that is associated with a high level of investment in HD radio, and the additional content needs to be created. You need a transmitter, importer, exporter, processing, all the SDL requirements. So it's, again, cost and complexity are the two challenges we're trying to tackle here. So the industry is looking for solutions to simplify things in the radio air chain, both in the analog and the digital air chain, and ideally both of them together. So back to you, Jeff.
Thanks very much, Philip. And so that explains a lot of the challenges we've seen in the RF chain and how we synchronize the HD radio signal up. And at that point, we start thinking, well, what technologies could we use to improve this? And to help explain that a little, I'm going to ask Jeff Stedman to put some thoughts to it.
Thank you, Jeff. I was, before the presentation, kind of pondering what does it boil down to for what tech really helps us. And I think I've reduced it to IP, and IP, but also cooperation and standards-based processing, so that we can cooperate with each other, because really we are in the same boat as being broadcasters. I thought it would be appropriate for some folks who may be on the call to just take a little bit of a look at composite FM, because I realize a lot of the shift in the talent that's working in our business are IT people. And just for a quick primer on the MPX signal and what are its components. Basically, a composite signal, a multiplex signal, is made of several components. And this is the thing that we need to feed into, from our processing into a transmitter. We need to feed it as optimally and as cleanly as possible to get maximum loudness, maximum cleanliness. But what are the components of this? There's the base, which is a left-right mono signal. A mono radio will hear this baseband signal down at from 0 to 15 kilohertz. There's the stereo pilot at 19 kilohertz that tells the receiver, hey, I'm a stereo signal. If you can decode me, go ahead and try. And then the left-right, left minus right signal centered at 38 kilohertz contains the piece of matrix with left right, left plus right, and left right minus right. You get discrete stereo. Then you get into the RDS signal at 57 kilohertz, and that's our now playing information. That's what's on your dashboard. And then we've got a couple other components that see a lot less use. SCA1 gets used for reading for the blind services, and SCA2 there are a couple examples, but not in wide play. But really, that's your spectrum. That's the composite spectrum that's broadcast and then decoded by an FM receiver, and 100 kilohertz wide it is. Recently, what we've been innovating on is really kind of an extension of AOIP, which is the FM signal MPX over IP as well. So let's go to the next one. And a product in particular, we just did a webinar on this last week. I know many of you may have been there. And this was a deep dive into the MPX node product that we introduced last year, pre-COVID. But it's basically we're taking the MPX signal and we're just we're using what's a micro MPX algorithm to be able to transmit this over IP at very modest data rates, really 400 kilobit per second ballpark. The codec itself will do 320 to 576. You always want to allow for some overhead for error correction, but we're effectively getting this composite signal over a pretty narrow pipe. And what we've seen from our users is they're starting to utilize this. They might have bought it for a backup, but they've started to employ it for their main signal. It's a lot cleaner than running your signal over an analog STL. The next slide will show us that. It contains the RDS signal. It doesn't have any the typical artifacts that you would consider with a left-right audio codec. Very clean, very purpose-built for broadcast FM. Here's a plot of an analog signal going over an STL, and on the right you can see pretty high noise floor. 60 dB down, you're really getting into some junk, and interference is going to wind its way up on your signal as well, and this will really impact your audio quality. On the right side is actually that micro MPX signal coming over this link, and you'll notice that that it ends at the RDS. We're not doing the first and second subcarrier, but the noise is non-existent, and we're down to we're down into minus 100, super clean, and this is going to preserve your loud, clean audio signal. And what I might add to this, we've had MPX over AES, digital MPX, for some years, but by putting it with IP, it's now routable, and that's huge. That's a real game changer. So let's hit the next one. This slide, I just want to kind of illustrate, and I think the next few slides will illustrate some of our evolution, because once we put this MPX over IP into our processor, it becomes the first stage in your STL. And really where we're trying to go with all of this is that this becomes your STL, this Cat5 cable, that you're able to transmit everything over a network. Let's hit the next one, Jeff. Now, part of that evolution too that I want to kind of go back to, and I said at the head of this that IP is really the rock that we're standing on. If I look at the Omnia 9, for example, when it started its life, all of its I/O was the stuff in the white typeface. It was analog, AES, in and out. And over time, we have added to it, we have evolved it, and now we see Livewire AES 67 and live coming in, Livewire plus AES 67 going out, and then MPX over IP and micro MPX coming out. And if I just transition to the next slide, now we've got a pure IP chain, IP audio chain with these innovations. And now if I just fade into the next one, what we're looking at is we actually don't need the hardware. And this is really where we're going. We can go virtual. And this is sort of the big idea. This is part of why we're here talking today. We are now introducing Omnia. We're calling Omnia Enterprise because this is really our software offerings. But the 9S is the 9 in a virtualized Omnia 9 in a virtualized environment. And Jeff, why don't you hit the next one? I think virtualization, for any of the detractors or folks who say, well, it'll never work and it can't work, we can back up a couple decades to, I think, when Greg Shea and Steve Church started talking about audio over IP and trying to leverage the big technology that's been driving our world and driving innovation. I like to think about when we're designing a hardware product, all the innovations that I see in, say, A to Ds or filter chips compared to the kind of information we see in, say, ARMS and network technology. There's just no contest. The game is being played on the whole IT infrastructure and the whole idea of virtualizing everything. Well, just look what we're doing today. We're in a virtual meeting spread all over the world having this conference call, and it's here today, and this is where we're going. This is how what we want to leverage. It's enabled by the standards-based audio over IP, things that we've been centrally involved to, especially to helping drive the AES-67 standard, contributing a lot of our own LiveWire technology to that. This whole move leverages the scalability of IP and the innovation that takes place to fuel all industry. And we're talking Wall Street, we're talking communication, telecom. This is a place where broadcasters get to hook on to this, get to ride the elephant, I guess you could say, of this just explosion in IT. For us, for our purposes, this means we get to run multiple instances of our processing once locked in a hardware box on a single server. So we can fire up and turn off processing at will. It means we can host our processing on someone else's server, whether it's a customer supplied or a vendor supplied or something that you're leasing in the cloud. It facilitates massive resiliency, and this resiliency is really a term that comes to us from the IT world. Super important. It's the idea that trading firms on Wall Street will not tolerate being down, and it's just a sea change in how humanity is progressed. But I guess the last bullet point is the ability this allows us to integrate processing into other workflows and with other partners, and that's where I think I will hand it back to Jeff and to Philip.
Thanks very much for that, Jeff. I do have a couple of questions and comments, and I think I'm actually able to address these, which on its own is remarkable enough. So Kelsey Black makes a comment that now he can finally have a liquid-cooled Omnia 9, and no question there. If you're throwing it in any computer, you can decide it exactly how you structure it. There was another comment about comparing it to baseband 192 over an AES EBU STL, and I know that's a competitor product, but as you can see, and as you will see, the flexibility with this, it's really comparing apples and oranges anymore. This is not something that's going to be tied to a conventional STL chain, and it's just huge in that regard. So
and the routability, yeah. I mean, that alone that's the distinction.
Exactly. So yeah, just the concept, and if you're following along at home, I'm pretty sure that a few of you have sort of got an idea where this is going already. But on that note, I'm going to turn it back over to Philip.
Jeff, if I could just take a quick moment here. You know, one of the things that when we introduced audio over IP, At the time, we had Steve, Greg, and I, we would refer to AES3 as dumb digital. And in a manner of speaking now, what we're doing with MPX over IP, it's the same thing. So something like MPX over AES or AES 192, that's dumb digital MPX. What we're talking about today is the next level. And then, you know, as we're handing it off to Philip, now this is taking MPX over IP and the whole transmission path to the next point. So, you know, anyone that's, you know, enamored with, you know, the whatever the prior question is, very soon that's going to be yesterday's news.
Yeah, and that ties in. Tom Dollinger asked a question, and Tom, I'm going to defer your question just because that specifically will be addressed later on, either today or in a future webinar, but it will be covered. So bear with us on that question. And Philip, over to you now.
Right. Well, Jeff, that was a great recap on the MPX over IP topic. And you know, going back to HD, the two are really linked at the hip. You know, we left off before with the NRC recommending moving a lot of the HD equipment to the transmitter site. And here we're showing, you heard a lot about fourth generation, where we're able to combine the importer and exporter. But with that recommendation, we're still at the transmitter site. And the audio processor is almost joined at the hip. If you want to minimize the differences in the FM and the HD1 air chains, really you want to keep the audio processor right with the exporter, really. The HD2, 3, and 4s don't matter so much, but the HD1 and the FM really need to be linked. So in this architecture here, all of these wonderful benefits that Jeff spoke about of running MPX over IP, we can't leverage that yet. So we will get into how we can, in our following webinars, how we can pull all these technologies together to come up with a solution. But at this point, let's just focus a little bit on fourth generation. And as I mentioned already, we've combined the importer and export already. So that's certainly a cost reduction. But if you want to make use of the combined importer and exporter, now all your HD2s and 3s and 4s and all the data services, your artist experience, you now have to bring all of this up the mountain somehow. And whether that's an IP STL, whether it's several STLs, whether it's a public internet provider, it has to get somehow up there in multiple disparate connections, really. One advantage, architectural advantage that fourth generation provided us is what we call remote audio capture clients. We're now able to take out what used to run on the importer as your audio capture client and run these outside of the importer. Excuse me. The benefit of that is now we can capture PCM audio, apply the HD codec to it, and we can now over IP transfer a compressed audio stream. So now these compressed audio capture clients can move back to the studio or even a remote studio if you're leasing a channel, and it can, you know, you can sort of break out your air chains separately that way. So that's certainly an approach. And the other thing that fourth generation gave us is different Exciter hardware implementations. But in terms of the air chain, it's really the remote capture client and combined importer exporter that make the big difference. So next slide, please. And overall, I think we just want to highlight that even though fourth generation is not a standard per se, it is certainly, it qualifies for made for radio because it gives us various platform options as manufacturers. It allows us to build purpose-built embedded systems, and there's certainly a lot of those in the market. It also gives us a flexible way of fielding the exact same software on what we call an open operating system platform. And that allows us to create an ecosystem of audio processing, audio over IP, playout, and fallbacks, disaster recovery. All of that stuff can very easily be implemented and tailored to a customer's needs as well. And we'll talk more about that. And it also leads into software-only platforms. Now we can get away, similar to what Jeff was talking about with the Omnia 9, it allows us to get away from purpose-built hardware. And that's really the key to get into virtualization. That is the key where we're going to go next. But what wraps all this together is that all of these IP blocks are delivered by Xperia DTS, and that is what ensures interoperability. So let's have a look at our HD Multicast, which is what we call an open operating system. It's running on Windows 10. And let's face it, most broadcast apps these days are still Windows applications, whether that's playout, whether that's audio over IP, whether that is even custom add-in cards. It's generally still a Windows world. Now that doesn't mean that we could not move to other operating systems, and we're definitely looking at that. But for the initial ecosystem, that's what it is. So the first improvement of combining the importer and exporter, and just hit the button there, right? Well, we certainly eliminated one box out of the equation, and that's certainly a cost improvement. It does reduce complexity a little bit in terms of setting things up, but there's still use cases where you might want to have them as separate components, and we can support that. But what we're looking at next is, well, how can we integrate various applications with it? The very first one that we're going to announce here is, well, for a limited time, we will be offering the Livewire Plus driver on our HD Multicast. If you are a Livewire user, then we will offer that free on a new HD Multicast. For the time being, we can only apply to HD 2, 3, and 4, and we'll talk more about HD 1 in some of our upcoming webinars. So keep that in the back of your mind, but for the time being, HD 2, 3, and 4. Well, talk to your sales rep to find out more about it, explain your situation, and let's see how we can help with that. Next slide. Another a proof point of this open operating system approach is that we're able to run the Omnia Enterprise 9S right on the Multicast. So we have that running in our systems here. Now you can see a screenshot with the remote control software in the background and the 4th generation control software in the foreground, all running in the same system. That now allows you to do HD 2, 3, 4 audio processing. But what's also interesting is that we can turn on that micro MPX option that Jeff talked about earlier. And that's an excellent application for if you're running a translator that's, let's say, FM only today. It can come from the same source. We can process it for the HD2 as well as the FM, and we can feed a MPX node with that translator if that works for you. All of that is because it's an open operating system approach. It was pretty much plug and play. We're able to interface the audio processor with our audio clients. And we certainly have lots of CPU power on this platform to support all of this. But there will be more on this topic to come in the following webinars, so I don't want to get too much ahead of myself. Next slide. Another proof point of this flexible architecture that we've already spoke about earlier this year is a partnership that we had with New Hampshire Public Radio, where they approached us and said, well, we've got these 5 transmitters. They all have slightly unique HD1 requirements. So they all need to have a slightly different HD1, top of the hour call sign identification, local news, and that sort of thing. But we would like to really just have an HD 2 and 3 and all those that's the same across the entire platform, across the state. So in today's architecture, and here we're that is again a split architecture where the exporter and the importer are separated. But in today's architecture, that is not a single importer cannot feed multiple transmitters. It's a one-to-one relationship. So we were not able to simply say, okay, fine, you can just multicast it to all these transmitters and be fine. It does not work that way. The reason for that is that the exporter is the heartbeat of the HD system. That's why I've drawn in those GPS antennas. And because of that, it slaves the importers to it. So the exporter is the master and the importer is the slave, and a slave cannot serve multiple masters. It's as simple as that. But what we were able to do in this new flexible architecture that Xperi is providing us, we're able to run 6 instances of the 4th generation software on the same platform. And they were all running virtualized in their own virtual environments. But what's also neat is the remote capture clients I mentioned earlier. We use those to then break out the 2 HD2 and 3 inputs to all 6 instances. And 5 of these 6 instances were driving real transmitters, but just because we could, we also set up a VSHD in our lab here in Hackett's Cove, Nova Scotia, and we send one of those data streams here so we could actually listen to it here. So again, it's a proof point of where the industry is going and what the benefits of virtualization are. It's really scalability. It's the ability to centralize and manage things better. Down the road, the intent of these virtual systems, it lends itself to running on server farms. You can run them all on a server farm with main and backup farms and all that sort of thing. So this idea of centralization and managing it all together is really being highlighted in this example. But more on this later, as this is really only a stepping stone in the direction we're going, but it shows you the direction. Next slide. So in order to centralize all of this, the challenge is, how do we move the HD radio air chain along with the FM back to the studio? And once we've accomplished that, and just hit the next slide there. There we go. Now we've really simplified the transmission site. Certainly there could be diverse paths to the transmitter, and there could be a backup air chain at the transmitter, but I really like the simplicity of, we can just feed everything with one signal. And once we've accomplished that and we've moved back the FM HD1 audio processor, now all those benefits that Jeff talked about earlier with micro MPX apply again. Now, if we can find a way to bundle this together with the HD, well, we've got something. So let's next slide, please. One of the key standards that will now come into place again, and that's very parallel to the micro MPX discussion that Jeff had, is what's called the export to Exgine E2X link. If you're familiar in the HD radio lingo, it becomes important again. This protocol has been specifically designed for IP SDL transmissions. The benefit of it is that all of the audio codecs and all the data services, everything is already compressed, and it sends the exact payload, the bits and bytes as being broadcast on air over the single stream. But it does not handle the FM. It only handles the HD. And while this E2X standard, it's really a de facto standard because it's not actually covered in the NRC specifications. It's an internal system component, so to speak. But it is a de facto standard in the sense that everybody's excited, no matter what vendor is actually using the standard today. With that, Nautel has done quite a bit of interoperability testing, and it works. It also ensures backwards compatibility. I can run one of our M50 exciters from the 2005 era with this protocol. It still supports that today. So we believe that this E2X link will gain new prevalence or new importance in a new architecture moving forward. Just to highlight here again, back with that, Nautel has already made improvements with the E2X, but at the heart, it is still E2X with what we call the reliable HD transport, where we're able to add extra retransmission requests for drop packets to the data stream, and allowed us to utilize lossy IP networks and recover data without any dropped or HD dropouts. So next slide. So we're going to leave you with a couple of questions, a couple of thoughts leading into our next webinars. And that is, if we put all these technologies together, the things that Jeff talked about and that Telos is bringing to the table, if we bring together some of the things we were talking about, well, can we move both the FM and the air chains together back to, let's call it a centralized studio for now? And can we utilize existing standards to accomplish that? And well, that's what we're going to be talking about in the next couple of webinars. And we certainly have some exciting demonstrations to show to you. And well, this is only the tip of the iceberg. Back to you, Jeff.
Thanks very much, Philip. Now, I do have, the questions have been coming in fast and furious. Some of them I am going to pass along and address. Some of them, Shane Toven with EMF is just pulling our leg and saying, oh, I've done all this stuff already. So we'll be after him for his license fees in a little bit. However, one really good point, Brett Patram asked if capture clients under Gen 4 platform on remote hosts could be done without additional licensing, and I can answer that, Brett. The answer is no additional licensing. The license fees are based on encoding and decoding instances, so where the capture clients are located is irrelevant to that. That's correct, right, Philip?
Yes, that is correct. Really, you can't use a capture client without an importer. So, the license fee is captured by the importer.
And so Kelsey Black is asking about when we can expect to see micro MPX decoded in the Nautel transmitters. Kelsey, I'm going to defer that one to a future webinar. And there was one other question on upgrading existing HD multicast. And Brian, I'm also going to defer that one. And on that note, I'm going to hand the reins back over to John White for a moment.
Thanks, Jeff. And thanks for your attention today. Hopefully you're seeing the passion that is fueling this collaboration. I think I talked to this idea that once in a while an opportunity falls into place for the timing for the convergence of challenges, and the technology and innovation gives us a special opportunity to try something new. And that's what we're hoping to take you through the next couple of webinars. We took a moment to take a look at some of the standards in the toolkit that we hope to bring forward. Micro MPX, MPX, E2X, and we gave a couple of examples of even today how some of these technologies can move us forward. The new Telos Omnia Enterprise 9S, examples of being able to have flexibility in the hosting and open software approaches that Philip talked about in the HD MultiCast Plus. So I hope you'll join us for the next two webinars. Our promise to you will be there'll be less slides and more showing. We'll be certainly spending some time with actual demonstrations in the next two webinars. So thank you. Back to you, Jeff.
Thanks very much, John. So definitely don't forget to log in for August 27th and September 10th when we start showing you the live demos, because this stuff is all awesome when we show it in a slideshow, but until you see it in paper, you don't know 100% exactly what we're up to. I'm sure you've got a lot to think about. There are definitely some aspects. Kelsey Black just called me a tease. I'm not going to argue. He may or may not be right. But I'm sure you can see a lot of applications where not just in HD, but in analog, this could be kind of an interesting concept, and there's some interesting things. So at this point, I want to take the opportunity to thank Jeff Stedman, Frank Fode, and Philip Schmidt, and John White for joining us. Also, guys, thanks very much for spending a good bit of your day with us, and it's greatly appreciated.
Thank you, and thanks to all that have attended.
Absolutely, that's my next move. Thanks very much to everybody that took some time to spend. And he never gets any credit, but behind the scenes, you never see him on camera. Ed Sylvester is back there. He's the puppet master that makes us all jump up and down. So thank you all very much, and we look forward to seeing you again in a couple of weeks. Have a great day.
Take care, everybody.
Yeah, bye-bye.